Severe wildfires alter watersheds as changes to vegetation and soils result in dramatic increases in the amount of water, sediment, and debris that is delivered to a creek or river channel. This excess water, sediment, and debris is carried downstream and often ends up damaging bridges, washing out culverts, and clogging diversions. It can also lead to flooded neighborhoods, damaged infrastructure, channel erosion, and impairments to municipal water quality and aquatic ecosystems. The goal of this planning study was to identify locations throughout the Upper Gunnison watershed where we can preemptively implement projects to reduce these post-fire impacts in our communities before a wildfire burns. The post-fire impacts we were concerned with in this study are those that deliver sediment, ash, and debris into our surface waters. We are concerned with hill slope erosion and the subsequent sedimentation in stream channels and reservoirs. We are concerned with debris flows and their threat to life and infrastructure. And we are concerned with threats that come from flooding and erosion when precipitation is not able to be absorbed into a recently burned landscape and instead rapidly enters our streams and rivers. This study identified locations in the Upper Gunnison watershed where the natural landscape can mitigate those post-fire impacts by acting as a sponge to absorb excess water, sediment, and debris. These natural sponge areas are typically scattered throughout watersheds and are the result of geologic, biologic, and hydrologic processes acting through time. By specifically identifying the locations of these unique landscape features, we could then assess if they are properly functioning, and if not, begin the process of rehabilitating or improving them, just like we would do for human-made infrastructure that we actively monitor and maintain to protect our communities. This study was done primarily using the science of geomorphology. Geomorphology is the study of how landscapes evolve and change over time. This science looks at the relationships not only between water and sediment, but also the relationships those things have with riparian vegetation and aquatic ecosystems, valleys and hillsides, and human influences and alterations. In better understanding these complex relationships, we can begin to improve our landscape management in order to better protect and maintain our water resources and communities. This study posed 4 big questions to help us determine where to prioritize actions to mitigate post-fire impacts in the Upper Gunnison watershed. 1. What are the natural sources of sediment supply to our streams and rivers, and how will a fire impact this sediment supply? 2. What sections of stream are interacting with their hillsides and valleys? 3. What sections of streams are most likely to transport sediment, and where might that transported sediment end up? 4. And what sections of stream are naturally able to capture and store excessive sediment? For example, in this photo from the Cameron Peak fire, we can see that sediment is being generated on the burned hill slopes and moving to the valley bottom either in sheets or in small debris flows. We also see that in this location, the stream corridor is directly connected to the adjacent hill slopes, and as a result, the hill slope sediment is then directly entering into the stream channel. While this sediment may be temporarily stored in this channel, we know this is not permanent. When heavy rains return, moving water will transport this sediment down the valley. Ultimately, this sediment will either be deposited on this alluvial fan or it will move into the river channel downstream, where it is likely to impact bridges, culverts, diversions, and aquatic ecosystems. It may also lead to issues with flooding or erosion that impact private property or possibly even threaten human lives during a flood. But as we mentioned earlier, there are natural features that disrupt this sediment movement and subsequently provide protection for downstream human infrastructure and the natural environment. These areas, due to their width, channel slope, flat topography across their floodplains, and their robust vegetation, are capable of trapping sediment that the stream brings in from upstream and the sediment that is directly delivered by the adjacent hill slopes. We can think of these areas as sponges, areas that can absorb and slow the excess water and sediment that comes off of burned hillsides. Where these areas exist, and especially if they are located between hillsides that have the potential to burn severely and critical water resources infrastructure such as reservoirs, it is important to ensure that they are ready to provide protection for our water in our communities if and when a wildfire occurs. In instances where these natural sponges exist and are functional, this study identified them as areas to be protected or conserved. In some locations, however, these natural sponges have been degraded through human actions, meaning that while they have the potential to store excessive sediment, they may not be in a condition to effectively do so. In these locations, this study developed recommendations for ways to rehabilitate these areas in order to regain their functionality. In some areas, only minor efforts or interventions are recommended, while in others, the degradation has been so severe that a serious and large-scale stream corridor restoration project is required to return the sponge to a functioning state. In other parts of the basin, there are no natural sponges. Here we recommend the community consider preemptive actions to mitigate post-fire impacts by reducing the burn severity on hill slopes and ridges. By reducing burn severity, we can reduce the amount of sediment that enters into a stream system after a wildfire. This burn severity mitigation can take many forms. Specific treatments to reduce burn severity such as prescribed burning, hand or mechanical thinning, pile burning, or biomass removal need to be determined in follow-up studies by experts in forest health, fire behavior, and fuels management. The projects or management ideas that are proposed here are listed as just that. Ideas or concepts that should, based on the science of watershed response and evolution, provide benefits to communities. These ideas have not yet been vetted by the community or by the landowners on whose properties these actions are recommended. Project participation and implementation of these watershed efforts is voluntary, though benefits to landowners and participants may result from the completion of the projects. The projects in these maps can be completed individually or as cohorts. While benefits will come from implementing individual projects, completing multiple or all of the recommended projects in a particular watershed will provide the most protection.